So in this last section, we need to cover the conversion of what's known as derived units. So the derived units are a little bit more complicated because they consist of multiple units. You've already seen one example in the previous lecture video, which was the unit for volume and the unit for area. So volume, you could do centimeters cubed, and when you break that down, it's actually centimeters times centimeters times centimeters. There's other examples that we're going to work with, and there's countless examples. A lot of our units are derived. They're combined units. So you have grams per milliliter, which is a unit that is used for density. And you probably know miles per hour, so mph, right? And so sometimes the derived unit has a different form, so it just looks like mph. But when we set up our conversion, we want to make sure we're always doing the nice horizontal lines. And so I wouldn't write it as mph. I would write it as miles divided by hours. And that's obviously a unit for speed, right? And another one, maybe this is a newer one, joules, right? I mentioned it briefly earlier in the lectures. That's a unit of energy. So joules is actually a combination of a bunch of different units. So it's kilograms times meters squared. So you can even break that down into meters times meters, right? Divided by seconds squared. So we have to be able to convert whatever they throw at us. And so that's what we're going to focus on right now. Alright, so the approach for the conversion of derived units is the same as what we've seen in previous lectures. We're going to use the number they gave us. So I'm going to start with 186, and I'm going to do milligrams. The main difference though is instead of writing this as a diagonal, that'll cause a bunch of confusion. We want to make sure that the divided line is nice and flat, nice and horizontal. Now that I wrote that number, I want to look at my destination. So what I'm noticing is that the deciliters in the denominator stays the same. So I'm going to circle that because there's no change there. And I don't want to cancel it out or do anything to it. I do want to get rid of milligrams and turn them to grams. So I'm going to set up my first conversion factor. I'm going to put milligrams down here. And then, can I go directly to grams? Well, yeah, grams is a base unit. So I'm only going to need one conversion factor. 1 gram has 1,000 milligrams. And then milligrams will cancel with milligrams, just leaving us with grams in the numerator. So now we have grams over deciliters, which is what we need. I'm going to do 186 divided by 1,000. And that's going to give me 0.186 grams per deciliter. Let's look at this next example. We're going to start with 452 meters. I'll do M for meters per hour. So per is going to be divided by, and so hours would go on the bottom. And we need to convert that to meters per second. So M divided by S. Let me think about this. So we can go from hours to minutes and minutes to seconds. Or if you know how many seconds are in an hour, you can go there a little bit faster. Totally up to you. And then we don't have to do anything with the numerator. The meters part is going to stay the same. So let me circle that. The other thing I want to mention is when you're setting this up, if it helps you, you could always put a 1 out here. This is saying that something is traveling at a rate of 452 meters in 1 hour. So I know that 1 hour, and I'm going to write it on the top now because I'm trying to get it to go away. I want to turn it into minutes. So I know that 1 hour has 60 minutes. And so hour will cancel with hour. Now I need to get rid of minutes. And so again, I want it to cancel out, so I'm going to write it in the top so we get that canceling. So minutes is gone, and I want to turn it into seconds. So I know that there's 60 seconds in 1 minute. Now we're left with meters per second. And when I divided this earlier, I got 0.126 meters per second. Such a cool problem. So I'm sure many of you have seen, if not purchased, helium balloons. But if you really start to think about how fast are those helium atoms moving inside that helium balloon? So 25 degrees Celsius, that's a little bit above room temperature, kind of a warm day, right? And the helium atoms would be moving at 1,255 meters per second. So it's kind of hard for me to appreciate that number. I didn't grow up in a country that used the metric system, so what does that really mean? So in order to help me conceptualize it, I want to convert that value to miles per hour so I can really appreciate how fast those helium atoms are moving. The temperature, even though it's interesting, is kind of extra information. I don't need temperature to accomplish that conversion, so I'm going to cross it out. And you're going to encounter this more and more, where problems just throw extra values at you that you have to learn to ignore or decide that maybe it is important. Let's start with the number they gave us. So 1,255 meters per second. And we want to convert it to miles per hour. You can start by converting meters to miles, or you can start by converting seconds to hours. I think I'm going to start with the denominator, with the time, just because I don't have to look anything up for that. So we're trying to get rid of seconds and go to hours. Now 1 hour has 3,600 seconds. Feel free to use this conversion factor as long as you remember that relationship. If not, first go to minutes, seconds to minutes, and then minutes to hours if you think you might forget that it's 3,600. All right, so with each step, make sure you're canceling out things and seeing where you're going. So seconds is gone, and now I have hours. So let me circle that because I'm there in that part. All right, now we got to do meters. I'm trying to get meters to miles. Now you're going metric to like a non-metric system, right? So looking at lecture packet 2, I see that we have a conversion between miles and kilometers. Makes sense because kilometers is used for like traveling distances around the world. So I'm going to use that one, between miles and kilometers. So since I'm in meters, first I'm going to have to go to kilometers, and then I can grab that other conversion factor, kilometers to miles. Not too bad. So meters is up here. I want to get rid of meters, and I want to change it into kilometers. 1 kilometer has 1,000 meters. Again, just checking how things are canceling. Meters will cancel with meters. Now I need to get rid of kilometers. So I'm going to put kilometers in the denominator. And I'm going to go from kilometers to miles. So on this lecture packet 2, we wrote that 1 mile has 1.6 kilometers. You don't have to memorize that. Something like that would always be provided. Kilometers is gone, and I'm just left with miles. So now the two things that I circled, miles per hour, were there. It's exactly where we needed to go. So in my calculator, I'm going to do 1,255 times 3,600. I'm going to close the parentheses, divide it by, use another set of parentheses, and I'm going to put 1,000 times 1.609. After I plugged it into my calculator, I got 2.807955. The number continued, times 10 to the third miles per hour. Here we have 4 sig figs. This is an exact number. I don't got to worry about it. Exact, and then 4 sig figs. So I'm going to adjust my answer, my final answer here, so that it has 4 sig figs. So I'm going to go with 2.808 times 10 to the third miles per hour. And by all means, you don't have to use scientific notation on this one. It would also have 4 sig figs if you just wrote 2,808 miles per hour. So either one of these final answers would be acceptable. We're going to start with 2.70 grams, nice horizontal line. And now in the denominator, it's centimeters cubed. So I'm going to break that down and write centimeters times centimeters times centimeters. I need to convert the numerator from grams to kilograms. So let me tackle that first. So I'm going to try to get rid of grams and turn it into kilograms. 1 kilogram has 1,000 grams. So constantly check where you're at by canceling out the units. So grams will cancel with grams, leaving me with kilograms. That's perfect. So we're good to go on the top. On the bottom, we need to get centimeters to meters. So I'll start setting that up. So I want to get rid of centimeters, turn that into meters. So 100 centimeters in 1 meter. And that gets rid of one of these centimeters. But since it's centimeters cubed, I need to do that 3 times. So I'm going to tack on 2 more of these conversion factors. 100 centimeters has 1 meter. All right, let's see how stuff is canceling out. Centimeters will cancel with centimeters, and centimeters will cancel with centimeters, leaving us with 3 units of meters in the denominator. That's perfect because that's going to wind up being meters cubed. So once I plug this all in my calculator, I got an answer of 2.70 times 10 to the third kilograms per meter cubed. So 17 kilometers per liter, and we want to convert that to miles per gallon. First things first, they gave us a conversion factor in the problem. So whenever you see something written like this, 1 gallon equals 3.7854 liters, that's a conversion factor. So we're trying to get rid of liters. So I'll put liters in the numerator so it'll cancel. And I want to change the denominator to gallons. So I'll write that down there. Then I grab the numbers. So the 1 is next to the gallons. And 3.7854 is next to the liters. Let's see what's canceling. How's that working out? So liters is canceling of liters. And I'm just left with gallons in the denominator. That's perfect because we want to get these units to miles per gallon. That's our goal. So we're good to go on the denominator. Now we got to get kilometers to miles. And we actually, on page 2 of lecture packet 2, we have that conversion factor. That's one of the ones we can use. So I'm getting rid of kilometers. I want that to cancel. And I'm going to miles. And we know that there's 1.609 kilometers in 1 mile. Kilometers will cancel kilometers, leaving us with miles in the numerator. When I did this, I got 39.99 miles per gallon. However, looking back, 2 sig figs with the 17 kilometers per liter. There's 5 with this conversion factor, 1, 2, 3, 4, 5, and 4 with this one. So I have to cut it down to 2 sig figs. So I'm going to do 40 miles per gallon as my final answer. And I'm going to either write it in scientific notation or put that decimal point to really emphasize that there's 2 sig figs in that value. So here we're asked to convert 1.8 quarts to cubic centimeters. So I kind of want to remind myself, a cubic centimeter is equal to centimeters cubed, which is equal to milliliters. Those are all equivalent units. And they're all units for volume. So is quarts though. The only difference is quarts is not part of the metric system. So I'm going to go to page 2. And on page 2 of lecture packet 2, there's a relationship between quarts and liters. Let me take advantage of that. So 1.8 quarts, and I want to get rid of quarts, so I'll put the quarts in the bottom, and I want to turn it to liters. So that relationship tells us that there's 1.057 quarts in 1 liter. Now looking at what's canceling, quarts will cancel quarts. Now I can imagine going from liters to milliliters. So let me do that next. So 1 liter has 1,000 milliliters. And now liters is gone. And these are all equivalent. So now I can just say 1 milliliter is equal to 1 cubic centimeter, or 1 cc. And at the end of the day, I got an answer of 1.7 times 10 to the 3rd cubic centimeters. Let's work on this density conversion. So we're going to start with 0.625 grams per liter. And we can even write 1 liter if it helps. Grams looks good to go because they asked us to convert to grams per cubic centimeter. So I'm going to circle this. I don't want to mess with the grams. I need to change the liters to centimeters cubed. So I know that 1 liter has 1,000 milliliters. And from there, liters is gone. And from there, I need to recall that 1 milliliter is equivalent to 1 centimeters cubed. So those are the same. This will cancel, leaving me with centimeters cubed. So at the end of the day, all I have to do is take the 0.625 and divide by 1,000. That gives me 6.25 times 10 to the -4th grams per centimeters cubed. So here we're given tire pressure in units of pounds per square inch. If you pay attention to those things, and you should, that's PSI, pounds per square inch. So they're asking us to convert it to grams per square centimeter. So let's go ahead and do that. We have 32 pounds and it's inches squared. So I'm gonna break that down. Inches times inches. First thing I'm thinking about is I know that we have a conversion factor between inches and centimeters. Let me grab that one and get rid of the inches first. So I'm going to put inches up top, so it's canceling, and centimeters in the bottom. And the page 2 tells us that there's 2.54 centimeters in 1 inch. That's just going to get rid of one of the inch units, so I need to use this conversion factor a second time. Excellent. That gets rid of the second inch, and now we're in square centimeters because our goal here is grams per centimeter squared. Alright, next we need to tackle the pounds, somehow convert that over to the metric system. Again, looking at the page there, we do have a conversion between pounds and kilograms. So let's take advantage of that one. Pounds is in the top. I want to get rid of it, so I'm going to put it in the denominator. And we're going to go to kilograms. So that states that there's 2.205 pounds in 1 kilogram. Almost on our way, right? Now we're in kilograms and we need to convert that over to grams. So that's just metric system. Kilograms is on top and I'm going to put it on the bottom so it cancels. And go to grams. 1,000 grams in 1 kilogram. One thing that I did that I just want to point out, I canceled pounds. It was over here with the pounds all the way over here. It doesn't matter. You can cancel from a really long distance. And don't forget to use parentheses. You're going to get an answer of 2.2 times 10 to the third grams per centimeters squared. This is a doozy of a problem. If you can do this problem, you're set on any of the problems that you'll see. What makes it so difficult is that we don't have a direct conversion between feet and miles. And so I do want to encourage you to just use the information on page 2 of lecture packet 2. So if we review that, there's lots of different routes you can take. I decided to go feet to yards. Yeah, that one's not on page 2, but I know that there's 3 feet in 1 yard. Just like I know there's 12 inches in 1 foot. Some of the really common ones are just assumed. And then from yards on that page, I noticed I can go to meters. And then from meters, I know how to go to kilometers, because that's just a metric system. And then on page 2, there was a relationship between kilometers and miles. So yes, there is a way to go if you knew how many feet in a mile, and if you had that information, you can use it, but let's pretend you don't have that information. 32 feet, and it's per second squared because it's acceleration. So let's do seconds times seconds. So always break that down kind of as a reminder. Now, let me do this part first since it seems kind of involved, right? So my first part of my plan here is to get rid of feet and turn it into yards. So 1 yard has 3 feet. So feet is gone. Now I want to get rid of yards and turn it into meters. So I'm going to put yards in the denominator and meters in the numerator. I'll look up that relationship. So 1 meter has 1.094 yards. And yards will cancel with yards. Now, meters to kilometers. and you're going to memorize it. 1 kilometer has 1,000 meters. That shouldn't be one that you have to look up. Just start memorizing. All right, kilometers to miles, that's one that you're going to look up. So we're going to get rid of kilometers and go to miles. So 1 mile has 1.609 kilometers. It's a doozy, like I said, but as long as you keep it super organized. So where are we at? Now we have miles in the numerator, and we're all set there. Let's tackle the denominator. And I want to get rid of seconds. They're in the denominator here. So in this conversion factor, I'm going to have seconds in the numerator. And I want to go to hours. So there's 3,600 seconds in 1 hour. Looking at how that cancels, that's only going to get rid of one of my seconds. So I need to use that conversion factor again. And that's going to cancel, leaving me with 2 units of hours in the bottom. Perfect, right? That's going to give us hours squared. When I did that all out, I got a value of 7.8534 times 10 to the 4th miles per hour squared. 2 sig figs. This is exact, 4 sig figs, exact, 4 sig figs. So I need to use 2 sig figs in my answer. So my final answer is going to be 7.9 times 10 to the 4th miles per hour squared.